Hello, welcome to the second session of solution of swing equation. Okay, so this is the last portion of our module 6 we have to discuss, and this is our swing equation. M into d square delta by dt square is equal to PA. This is our swing equation. In order to solve this, why are we solving this? We are solving to find out critical clearing angle and critical clearing time. Okay, so in order to solve this, we can use direct solution is very difficult, so we use numerical techniques. So these are the important or the main types of numerical techniques we are used. In this, first I have discussed on by point method. This we have already discussed, in which first we are assuming the accelerating power is a constant, then we are finding out omega or the angular speed or angular position at the end of the interval. With this delta value we are calculating the accelerated power for the at the end of the last interval, that is at the beginning of the next interval, and then we assume it is same for that particular time interval and it continues. Okay, so similarly, similar to point by point, we have another method and its name is Runge method. Okay, so first I will discuss you with general mathematics, that is just the introduction of Runge method. So for solving swing equation, I can use or second order Runge equation or approximation or fourth order. Okay, but what we are interested in solving for Runge fourth order approximation. Okay, so what we are doing is we are going for Runge fourth order approximation. I am not going to all the derivations of how to do Runge method, but I will just give you the equation. So this we use to solve differential equation, isn't it? So I am writing my one differential equation, that is dy by dx is a function of my x and y. If I am writing like this, my dy by dx is a function of x and y, then if y of x0 is equal to y0 and y of x1 is equal to y1, then this y1 I can write it as y1 is equal to y0 plus some constant k. Okay, and what is the value of this k? This k we should take it as k is equal to 1 by 6 into k1 plus 2k2 plus 2k3 plus k4. Okay, and we have to find out what is this k1, k2, k3 and k4, where k1 is equal to, what is k1? H is the time interval. Okay, or here we will, in our swing equation it will be delta t similar. Okay, so h into function of x0 y0. Okay, so first we should have a predetermined value. Shall I repeat? Okay, I will write the equations, then I will tell you. So for k1 it is h into f of x0 y0, and for k2 we have to multiply h into function of x0 plus h by 2 and y0 plus this k1 value, k1 by 2. We have to find the equation. And for k3 what we have to do? H into h from x remains the same, x0 plus h by 2, and that is y0 plus k2 by 2, and k4 is equal to h of function of, now this will change, x0 plus h comma y0 plus k4. This set of equations you have to by heart it, and you have to solve the entire equation to find out the successive steps. Okay, so what is a Runge method? In a Runge method, the independent variable, that can be x or y, isn't it? Here x is the independent variable. In a Runge method, independent variable is given a set of predetermined value, that is x0 value will be given. If x and y are independent variables, then x0 value and y0 value will be given, that is independent variable will be given a set of predetermined values and corresponding dependent values are evaluated from this set of equation. Corresponding dependent values are evaluated. In our equation, x and y are the variables in which x is the independent variable and y is the dependent variable. Y is a function of x0. x0 is an independent variable. So x0 value will be already given, predetermined value. Then what we have to find out? We have to find out different values for y1. How will we find out different values for y1? y1 is equal to previous value plus one constant k. What is that constant k? K is equal to 1 by 6 into k1 plus 2, k2 plus 2, k3 plus k4. Okay, then what is the value of k1? K1 is the h into, what is the h? Time interval into f of x0, y0. We have to give this equation. There will be a function and we have to give the values x0 and y0 for this particular function, and we have to find out k1. Then we have to substitute this k1 here and we will get the value k2, and we have to substitute the k2 value here and we will get k3. Then we have to substitute, this is not k4, sorry, this is k3. We have to substitute this k3 here and we have to find out the values. Okay, so this you can already remember. K2 and k3 x values are same, k1 by 2 and it is k2 by 2. That is the only difference. Then in k4 you have to by heart this equation, and we are substituting k1, k2, k3, k4 in this equation and we will find k value. And we substitute this k value here and you will get the new value y1. Okay, so shall I do a problem? Just a simple problem so that you people will understand what is a Runge kutta method. Okay, so my question is, okay, so this is my equation, this is my question, that is we have to use fourth order Runge kutta method to find the value of y of 6. Okay, so what is the equation? That is dy by dx. dy by 2 into dy by dx is equal to 2 into dy by dx value is equal to root of y plus x. Okay, so what is a value we have to find out is 0.6. Okay, so we have to find out the value for 0.6. So how many steps we have to do if h is equal to 0.3? That is, h is the difference between, or the time gap between x1 and x2. So if I am drawing my equation, or in step 1, what steps we are given? We are given x0 is equal to 0 and y0 value is equal to 1, and then we were given h is equal to 0.3. And what is the function? We have to rewrite it in the form of dy by dx, isn't it? So that is dy by dx is equal to root of y plus x by 2. Okay, 2 is out of the root. Okay, dy root of y plus x divided by 2. Okay, so what we have to do is, we have to, excuse me. So what we have to do is, we have to find out the values for x and y. So x value and y value, when x is equal to 0, y value is 1. Now after 0.3, then x will be 0.3, that is x1. x1 will be 0.3. At that time we have to find out y1 and we have to find out x2 0.6. Then you will get y2. That is our question, that is y of 0.6. I hope you understood. Okay, so we have to find y of 0.6. Okay, so what we have to do is, first I have already given you the equations, isn't it? What is the equation? We we have to find out we have this value. Now we have to find out this in our step 1. So when x1 is equal to 0.3. Okay, so in our equation, how will I start now? So we have to find out for k values, isn't it? K1 value, if I am finding out, because we have to find out y1 is equal to y0 plus k. What is this k value? K is equal to 1 by 6 of k1 plus 2k2 plus 2k3 plus k4, isn't it? 1 by 6 into k1 plus 2k2 plus 2k3 plus k4, and we have to find out k1. What is k1? K1 is h into function of x0 comma y0. What is h? H value is 0.3. 0.3 into function of what is x0 is 0 and y0 is 1. So if I am rewriting it, that is 0.3 into what is function? Function is root of what is y? Y value is 1. 1 plus x is 1 by 2. Okay, and what is this value? 0.3 into 1 by 2. What will be the value? That is 0.3 into 1 divided by 2. That is 0.15. So 0.15, we get k1 value as 0.15. Then what we have to find out is, we have to find out k2. K2 is equal to h into f of x0 plus h by 2 comma y0 plus k1 by 2, isn't it? This was the equation, x0 plus h by 2 comma y0 plus k1 by 2. So what is h? 0.3 into function of what is x0? X0 is 0. 0 plus h by 2. What is h by 2? 0.3 by 2. That is 0.15 comma y0. Y0 value is 1. 1 plus what is k1? K1 is 0.15 by 2. So that value will be equal to 0.3 into f of 0.15 comma 0.15. That is 0.15 divided by 2 plus 1, that value will be 1.075. Okay, that value will be 1.075. And if we are substituting this, that we will get it as 0.3 into root of 1.075, that is y, plus x value is 0.15. So I am writing it plus 0.15. You will get 1.225. Root answer, you will get it as 1.106 divided by 2. Divided by 2, I will get it as 0.55 into 0.3. Then I will get it as 0.1660. So that is 0.166019. So 02. This is the value for my K2. Okay. So now we have found out K1 value and K2 value. Then what is the next step? For the next step, we have to find out K3 value, isn't it? So what is K3? K3 value is equal to h into f of x0 plus h by 2 and y0 plus k2 by 2. This is our equation. So that is equal to 0.3 into f of x0 plus h by 2 is same here, isn't it? That is 0.15 comma y0 is 1 plus what is k2? 0.1602 by 2. So 0.160 divided by 2 plus 1. What is the value? 1.083. So K3 value is equal to 0.3 into function of 0.15 comma 1.083. Now we have to substitute it in our equation and we have to get the correct value. That is equal to 0.3 into what is function? Root of y plus x, isn't it? The function is root of y plus x. What is this root of y plus x? That is root of y is 1.083 plus x is 0.15 divided by 2. That is equal to, this is plus 0.15 and root answer you will get divided by 2. You will get a value and into 0.3, that is equal to 0.1666. Okay, so what is the value? That is equal to 0.1666 value. That is our K3 value. Now we have to find out K4. What is K4? H into function of x0 plus h into function of x0 plus h, comma y0 plus K3. And what is the value? That is 0.3 into function of x0 is 0 plus h is 0.3. So 0.3 comma y0 is 1 plus 0.1666. What is the value? 0.3 into f of 0.3 comma 1.1666. Isn't it? And if I am substituting it, 0.3 into root of 0.3 plus 1.166 plus 1.166 plus 0.3 and root answer divided by 2. Here 2 is there. I will get into 0.3. That value is 0.1816. Okay. And K4 value I will get it as 0.1816. So K4 value we have found out K1, K2, K3 and K4. Now we can find out our K value. K is equal to 1 by 6 into K1 plus 2K2 plus 2K3 plus K4 value. That is equal to 1 by 6 into what is K1 value? K1 value is 0.15 plus 2 into what is K2 value? 0.16602 plus 2 into what is K3 value? 0.1666 plus what is K4 value? 0.1816. This value will get it a K value. So what is 0.1816 plus 2 into 0.166 plus 2 into 0.16602 plus 0.15. That value divided by 6. That is that value I got it as 0.16595. That is 0.16595. That is my K value. Now what we have to find out? I have to find out Y1. Y1 is equal to Y0 plus K value. That is Y0 value was 1 plus 0.16595. We will got it as 1.16595. That is the value for Y1, which means Y of 0.3 is equal to 1.16595. What is our question? Our question is to find out Y of 0.6, isn't it? This is our question. So in order to find out Y is equal to 0.6, again we have to do the same steps. So in order to do the same step, so I am doing the same steps again for the second iteration. That is, first I have to find out my K1 value. K1 value will be is equal to here. K1 value that is equal to h into f of x0 comma y0. That is 0.3 into f of what is x0 here. Instead of x0 now it will become what is it? X1 and Y1. Okay, so what is X1 value? That is 0.3 and 1.16545. Okay, so that value we will get it as root answer divided by 2, that is 0.605 into 0.3. The answer is 0.1816. Okay, so 0.3 into root of 0.3 plus 1.16545 divided by 2, we will get it as 0.1816. 0.1816. Okay, K1 value. Now we have to find out K2. K2 is equal to H into F of x1 plus h by 2 and y1 plus K1 by 2. So that is equal to 0.3 into f of what is x1? x1 is 0.3 plus what is h by 2? h by 2 is 0.3, that is 0.15 comma y1 value is 1.16545 plus k1 value is 0.1816 by 2. This function we have to find out, that is 0.3 into function of, that is 0.45 comma 0.1816 divided by 2, that value plus 1.1645, oh sorry, 545, you will get it as 1.256, 1.2563. Okay, so that is equal to 0.3 into root of 1.2563 plus 0.45, that is plus 0.45. You will get a value, root answer, you will get a value divided by 2, you will get a value into 0.3. That value is 0.1959. 0.1959, you got the value for K2. Now we have to find out K3, that is H into F of x1 plus h by 2 and y1 plus k2 by 2. So that is 0.3 into f of 0.45, because this remains the same, 0.45 comma h1 is 1.6545 plus this 0.1959 by 2, this value. So divided by 2, you will get some value plus 1.6545, you will get another value, and I am substituting in my function, that is 0.3 into root of 1.7546 plus 0.45 divided by 2. Okay, plus 0.45 root answer divided by 2 into 0.3, you will get 0.2226. So that is a 0.2226 value, K3. Now we have to find out our K4 value. K4 value is equal to H into F of x1 plus h and y1 plus K3 value. Okay, so that is equal to 0.3 into f of what is x1 plus h. x1 plus h is x1 value is 0.3, 0.3 plus 0.3 is 0.6, and what is y1 value? 1.16545 plus K3 is 0.2226. So that value will be equal to 0.3 into, taking another paper, 0.3 into function of 0.6, that value plus 1.16545, that value will get is as 1.3881, 1.3881. Okay, and if I am substituting, that is K4 is equal to 0.3 into root of 1.3881 in plus 0.6 by 2. So plus 0.6 divide root answer divided by 2 into 0.3, you will get a 0.2115. That is equal to 0.2115. So we got K1, K2, K3, K4 values. Now what we have to find out is, we have to find out K. K is equal to 1 by 6 into, what is the value for K? K is equal to 1 by 6 into K1 plus 2K2 plus 2K3 plus K4 value. So that is equal to 1 by 6 into what is K1 value? 0.1816 plus 2 into 0.1959 plus 2 into 0.2226 plus 0.2115. Okay, that value will be equal to 0.2115 plus 2 into 0.2226 plus 2 into 0.1959 plus 0.1816. That value divided by 6, you will get it as 0.2050. That is 0.2050. Okay, and what is my next value? Y2. Y2 is equal to, my answer 0.6, that is equal to Y1 plus K. What is Y1? Y1 value is, we know, 1.16545 plus 0.2050. So plus 1.16545, you will get it as 1.37. It's equal to 1.37. So what is y 0.6? That is 1.37. Okay, so this method is very easy. Just we have to follow some equations, and first we are assuming certain predetermined values for the independent variables, and dependent variables are solved from this predetermined values, and we continue to do this iteration. Okay, but there is a one defect for this Runge-Kutta method is it is a lengthy process. See, by doing 2 steps we have to solve, for each step we have to solve 5 equations. That is, first we have to find out K1, K2, K3, K4, 4 equations. Then we have to find out K value and add it with the previous value to get the present value. Okay, so this is how we can do Runge-Kutta method. And also here I have taken H as equal value 0.3, 0.6. Okay, if in the question, instead of, in the question we are asked to find 0.6, isn't it? If instead, if we were asked to find out y 0.2 and y 0.5, then we have the value, H value, we have the value y of 0. Okay, so y of 0 we have the value as 1. Okay, so while doing this, here first value x0 is equal to 0, we got y0 value as 1. Okay, and when x1 is equal to, next we have to find out 0.2. So we have to find out y of 0.2. In that time, the h value is equal to 0.2. The difference between these two. And in the second step, if we were asked to find out x2 value, that is 0.5, then we have to find y is equal to 0.5 now. So in this time, in the second step, what we have to do is h is 0.5 minus 0.3. So h is 0.3. Why I am explaining is h should not be always equal, and for equal, h should not be an equal value for all the intervals. It can be a varying value also, that we have to keep in mind. Okay, so this is a 30-minute session. So I have just given you how to do a Runge-Kutta method in a max to solve an ordinary differential equation. Now, what we are going to do is, how can we apply the same thing in our swing equation, and how will we solve this? And so while solving the swing equation, we are using the same Runge-Kutta method, but we are having two functions, isn't it? We have to find out the value of omega and delta. So if dy by dx, we are taking two functions, then it is x, y and z. And I have another one more function, that is dz by dx. Okay, that is equal to another function of x, y and z. In swing equation we use this type of equation. Okay, then what we are going to find out is, if this is the first equation, then we have to solve y1, the next step of the solution. Y1 is equal to y0 plus 1 by 6 into k1 plus 2k2 plus 2k3 plus k4. We have to solve this. Similarly, for the next set of equation, next equation will be z0 plus 1 by 6. Instead of k, I am notating it as L. Okay, so instead of k, I am notating it as L. So L1 plus 2, L2 plus 2, L3 plus L4. Okay, and we know what is k1 here. We have to solve like this, where k1 is equal to, k1 is the function here, isn't it? So k1 is h into f of x0, y0, z0. And what is k2? k2 will be equal to f of h into f of x0 plus h by 2, f of x0 plus h by 2. Then instead of y, that is y0 plus k1 by 2, and what is z0 plus thing related to z is L, isn't it? So L1 by 2. So for k1 we have to find out what? For k1 we have to find out f of x0, y0, z0 into h. Similarly, in order to find k2 we have to find out L1. L1 is equal to h into f of h into g of x0, y0, z0. So first we have to calculate k1, then L1, then we have to find out k2. Similarly, we have to find out L2 also. L2 is h into g of h0 plus x0 plus h by 2, y0 plus k1 by 2, and z0 plus L1 by 2, isn't it? So L2 value will be g of x0 plus h by 2, because f of x is a one differential equation and the g of x is another differential equation. So we have to substitute in the second differential equation to find out the value of L2. We need k2 and L2 to find k3. So k3 will be equal to h into f of x0 plus h by 2, y0 plus k2 by 2, and z0 plus L2 by 2. And for L3 we have h into g of x0 plus h by 2, y0 plus k2 by 2, and z0 plus L2 by 2. Okay, then how can we find out k4? K4 is equal to h into f of x0 plus h, y0 plus k3, and z0 plus L3. We have to find out we have to substitute these values in this function and we have to solve the equation. Similarly, L4 is equal to h into L4 is equal to h into g of x0 plus h, y0 plus k3, z0 plus L3. Okay, now what we have to do? Then we have to find out, we have found out k1, k2, k3, k4. Now we have to substitute it here and we will get next value of y1. Similarly, if we are substituting L1, L2, L3 and L4, then we will get the value for z1. That is the next solution for z1. Okay, so this one we are using in our swing equation. Okay, so I will go the detail in next class. So till then, take care, happy learning. So this section I will give you today afternoon itself.